Alright, so in this problem, I have phi to the power of x plus phi to the power of x is equal to 7. So to start, I'm going to factor out phi to the power of x from my left-hand side. So now I have phi to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have phi to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I have log 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20. Alright, so in this video, I'm going to solve the equation 3 to the power of x is equal to 30. So, to solve this equation, I'm going to start by taking the log on both sides. So I get log of 3 to the power of x is equal to log of 30. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 30. Now that x is an actual term, I can solve for it by getting rid of this log 3. So I'm going to divide both sides by log 3. So then these two cancel out, and I get x is equal to log 30 over log 3. Now, log 30, I'm going to rewrite that as log of 3 times 10. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 10 is equal to log 3 plus log 10. Now I have this over log 3. So now this is equal to log 3 over log 3 plus log 10 over log 3. Now log 3 and log 3, these two cancel out, so I get x equals 1 plus log 10 over log 3. And log 10 is 1, so I get x is equal to 1 plus 1 over log 3. Now 1 over log 3 is equal to 2.096, so x is equal to 3.096.